Welcome. Today we're looking at the additional mathematics very first paper when it started way back in the year 2012. So we're going to work through this add math paper, and yeah, it's nice and easy. So this paper has four sections and well, 5 sections, and you should do everything from section 1, section 2, section 3, and then the final section, you choose one of 2 questions. But for our sake, we'll do everything. All right, so let's get into it. So as you can see, this is section 1. Section 1 constitutes of 2 questions. The 2 questions will be relations and functions, factor and remainder theorem, surds, logs, indices, linear reduction. That will be question 1. Question 2 is like quadratic equations, inequalities, sequence and series. That's generally in question 2. All right, so section 1 is really just algebra. Section 1 is algebra. So let's go ahead and do this question. So it says the functions f of x and g of x are defined by f of x is x cubed plus 1, but f of x is defined between 0 and 3, and g of x is equal to x plus 5. And then it says, where R is the set of real numbers, determine the composite function g f of x. So the composite function g f of x means we're putting g into f. That's all it means. So let's do that. So the composite function g f of x means we're putting f into g. G f of x, this is what we want. So we're going to put f into g. All right. So this will be equal to g of x is x plus 5. So g f of x is going to be f of x plus 5. That's going to be g f of x. So we'll put f of x into g, and f of x is x cubed plus 1. So this is going to become x cubed plus 1 plus 5. X cubed plus 1 plus 5 is x cubed plus 6. And that is g f of x. It then said, state the range of g f of x. It wants the range. Now, first thing I want to tell you is before you can find the range, you need to know the domain. All right? The domain of g f of x, the domain for this function, the domain is going to be x, and x is going to be between 1 and 3. This is the domain between 1 and 3. That's the domain. The domain of g f of x will be the domain of f of x. So this is the domain. So the domain is what we're going to use to find the range. All right. How do we use the domain to find the range? So that means then g f of x, this is how we're going to find the range now. G f of x is of course going to be between, first thing you need to do is find out what is g f of 1. G f of 1 will be put 1 cubed plus 6, that's 7. And then put in 3. 3 cubed is 27, and 27 plus 6 is 33. And so this is the range. G f of x is between 7 and 33. This is the range. All right, this is the range of g f of x. And that's the answer. Nice and easy. The next part is asking us to determine the inverse of this. For the inverse, which is quite simple, we're going to call g f of x y, all right? We're going to call y is equal to x cubed plus 6. So y is equal to x cubed plus 6. To find the inverse, the first thing they tell us to do is interchange x and y. So what we're saying is then x is equal to y cubed plus 6. And then we need to make back y the subject. To make y the subject, we're going to subtract 6 from both sides to get x minus 6, and that's equal to y cubed. But then we need y. X minus 6 is y cubed. So to get y, we're going to have to cube root both sides. And so this is y. All right. Now this y is the inverse. This y is the inverse. And so what we can therefore conclude now is that g f, the inverse of this, the composite function inverse, is going to be equal to the cube root of x minus 6. That's the inverse, the cube root of x minus 6. Nice and easy, soft. Nice and easy, no issues with this question. So it's the cube root of x minus 6. All right, now let's continue with part B now. Part B. Part B, the next part of the question, is asking us if x plus 2 is a factor of f of x, find the value of a. All right, if x plus 2 is a factor of f of x, find the value of a. That's part 2. Now, if x plus 2 is a factor of f of x, then what that means is that f of minus 2 is equal to 0. F of negative 2 is equal to 0. How do we know that? F of negative 2 is equal to 0 because x plus 2 is a factor. And so we're going to substitute in the function for f of x. We're going to write 2 times negative 2 cube, 2 times negative 2 cube, minus 3 times negative 2 square, minus 4 times negative 2 plus a, and of course this is equal to 0. And this is how we're going to find the value for a. And that's equal to 0. So let's now continue now. So negative 2 cube is 8. 8 times 2 is 16. And then minus 2 square is 4. 4 times minus 3 is minus 12. And then minus 2 times minus 4, that's positive 8. Plus a, and that's equal to 0. Nice and easy. So all we need to do is find the value for a now. So 16 minus 12 plus 8, that's 12. And so a is equal to negative 12. That's the value for a. A is equal to negative 12. That's all they're asking us to do. Nice and easy. Soft. And so that's the solution of the first part so far. Now let's have a look at part C. Part C says to solve the equation 3 to the 2x minus 9 times 3 to the minus 2x is equal to 8. So let's see how we solve this now. So first thing I recognize is Well, 9 times 3 to the minus 2x. By laws of indices, I can rewrite that a different way. So I'm just going to rewrite it back as 3 to the 2x minus 9. And instead of saying times 3 to the 2x, I'm going to write minus 9 over 3 to the 2x. 3 to the minus 2x can be written as 1 over 3 to the 2x. So I can write it this way, and that's equal to 8. Nice. So now I have this equation to solve. To solve this equation, I'm then going to multiply the entire equation by 3 to the 2x. So multiply this equation now through by 3 to the 2x. By multiplying this equation through by 3 to the 2x, I'm going to have 3 to the 2x all square. So now I have 3 to the 2x all square minus 9 is equal to 8 times 3 to the 2x. Nice and easy. All we did was multiply through by 3 to the 2x to make the equation easier for us to solve. Now I'm going to call 3 to the 2x y. Just call it y. All right? It looks complicated with the 3 to the 2x and all of that stuff. So we can say, let y be that 3 to the 2x and see if we can solve it a little more easier. If we call 3 to the 2x y, then the equation above is going to become y squared minus 9 is equal to 3 to the 2x is y, and so it's equal to 8y. Now this looks very easy to solve. This looks like a quadratic equation. So now it just looks like we have y squared minus 8y minus 9 is equal to 0. Now this is so easy to solve. This becomes so easy to solve because now we can factorize it and say this is just y minus 8 okay, to get y minus 9, sorry, and y plus 1. Y minus 9 times y plus 1. Those are the two factors. So we factorize it, and this is what we get. Y minus 9 times y plus 1. And that's, of course, equal to 0. Nice and easy. Now that we have this now, it is easy to solve for x. It's very easy. All right? So we just need to remember that, of course, what was y? Y we said was 3 to the 2x, all right? So when you're saying that y is equal to 9, in reality, what we're saying is 3 to the 2x is equal to 9. This is what we're really saying. But if 3 to the 2x is equal to 9, x must be what? X must be 1. That's the only way 3 to the 2x can be equal to 9, because if x is 1, this is really 3 squared, and 3 squared is 9. From over here, so now we're really saying that y is negative 1. And if y is negative 1, then what we're really saying is 3 raised to the power of 2x is negative 1. But if 3 raised to the power of 2x is negative 1, this is not valid. This is crazy. All right, this is crazy. This has no solution. You can tell them. Don't be afraid to say that this is crazy. All right, and so the solution is x equal 1. This is crazy. You cannot raise a number to a power and get a negative answer. So this is crazy. Now, once you finish and you get that x is 1, you can test your answer. So put 1 in here. 3 to the 2 is 9 minus 3 to the 2 is 1. 3 times 3 squared is 9. 9 over 9 is 1. 9 minus 1 is 8. So you know your answer right now. So x is indeed 1. All right. So you can just tell them. So the answer is x equal 1. That's the solution. X equal 1. Nice and easy. And that takes care of part 2. This is 5 marks, by the way. Now, part 3. Part 3 of the question, it's asking us now, it says express x cubed minus 10 times minus 10 raised to the x minus 3 in a log form. Okay. So it wants us to express x cubed, which is equal to 10 to the x minus 3, and they want us to express this in log form. Now, in order to express this in log form, what are we going to have to do? The first thing we can do, always just take log of both sides. Take the log of both sides. Let's just take log of both sides. By taking log to base 10 of both sides, we're going to get log to base 10 of x cubed. Log to base 10 of x cubed is equal to log to base 10 of 10 to the x minus 3. Now, don't worry at all. Now, this is very easy. Now, according to log, we can bring down the power, and so we can rewrite this as 3 log to base 10 of x is equal to, we can bring down the power right here, the x minus 3, and write this as x minus 3 times log to base 10 of 10. But now look at this now, guys. Log to base 10 of 10, this part right here is 1. Log to base 10 of 10 is just equal to 1. Nice. And so 3 log to base 10 of x is just x minus 3 times 1, which is just x minus 3. So this is now log to base 10 of x. Okay? Now we need to get rid of this 3. So to get rid of this 3, we divide both sides by 3. So we're finally going to get that log to base 10 of x is equal to, when we do the division, it's going to be equal to 1 over 3 times x. Because we divide both sides by 3, x divided by 3 is 1 over 3x, minus 3 divided by 3 is 1. And so this is the solution for part 1. All right, so log to base 10 of x is equal to 1 over 3x minus 1. Now the next part of the question says, hence state the value of the gradient of the graph of log to base 10 of x versus x. Now guys, if this was a graph, or if we were plotting this as a graph and this is y, we know the equation of a line is y is equal to mx plus c. Y equal mx plus c. And so clearly the gradient of this line, can we just call the gradient m? We can if we want. Just call the gradient m. So the gradient, I'm going to write grad for gradient. The gradient is just 1 over 3, which is 2ez. Nice. So this is all we have now. This is the gradient. Nice and easy. Soft. All right. That's the gradient. That takes care of the third part. And so this takes care of question 1. No issues with question 1. Nice. Now let's go on to question 2. Question 2, it gives us a quadratic equation. And the quadratic equation that they give, it says the quadratic equation is x squared minus 4x plus 6, and it has roots alpha and beta. So if it has roots alpha and beta, it has to calculate the value of alpha squared plus beta squared. Now, I don't know how to calculate alpha squared plus beta squared, but this is what I do know, that the sum of the roots of any quadratic equation, alpha plus beta, is equal to minus b over a. All right, where b is the coefficient of the x term and a is the coefficient of the x squared term. All right, so I'm just going to put down the equation over here and show you how we deciphered that. The equation is x squared minus 4x plus 6. Now this equation is where you know your coefficients of your x squared term, your x term, and your constant. From this equation, a equal 1 because the coefficient of x squared is 1. And this is saying b equal negative 4 and c is equal to 6. All right, so you're going to need to know these formula in order to be able to can work out the sum and the product of the roots. So alpha plus beta is minus b over a. And so minus 4 is positive 4. So that's alpha plus beta. Now the product of the roots, alpha beta, is equal to c over a. Alpha beta is c over a. C over a is 6 over 1, which is 6. Now look at what they're asking for. They're asking us for the value of alpha squared plus beta squared. So this is what they want us to calculate, alpha squared plus beta squared. Now look how we're going to find this. To find this, I'm going to go back to this. What is alpha plus beta all squared? Alpha plus beta all squared. How would you expand this bracket? To expand this bracket, alpha plus beta all squared would be alpha squared plus 2 alpha beta plus beta squared. This is how we expand that bracket. All right. But now, guys, look what we do now. We know that alpha plus beta is 4, and so alpha plus beta all square is going to be 4 square. That's equal to, we don't know what is alpha square, so we write that back. Alpha square plus 2 alpha beta. What is alpha beta? Alpha beta is 6. What is 2 times 6? 2 times 6 is 12. Plus beta square. So alpha square plus beta square, we can find that now. Look at this, alpha square plus beta square. Yeah, if we bring over the 12 over here, so 4 square is 16. 16 minus the 12 is 4. And so 4 is equal to alpha square plus beta square. And that's the answer. 4 is equal to alpha square plus beta square. And this gets rid of part 1. Nice and easy, soft. No real issues. Now the second part of the question goes further by asking us to find the range of values for x, for which 2x minus 5 over 3x plus 1 is greater than 0. Now let's look at the second part of the question. Now the second part of the question, when you're solving this inequality, when you're solving a rational inequality, the first step is to convert it to a quadratic inequality. To convert it to a quadratic inequality, we're going to multiply both sides by the square of the denominator. So right here, when we have this, we're going to multiply both sides by the square of the denominator. So we're going to multiply both sides by 3x plus 1 all square. That's the first step. You multiply both sides by 3x plus 1 all square. What that will give you is 3x plus 1 all square times this, result in 2x minus 5 times 3x plus 1 is greater than 0 times anything is just 0. And so there, that's how we convert it from a rational inequality into a quadratic inequality. All right, and this is a quadratic inequality we have. Now, I always like to draw a sketch before I write down my solution. Just like to draw a sketch of a quadratic graph. Sketch of the quadratic graph, and the roots would be 5 over 2 and minus 1 over 3. This is what the roots would be, 5 over 2 would be here, and the -1/3 would be here. This is the roots. All right, think of this as f of x greater than 0. And then we know that f of x equals 0. This would be the line y equals 0. But they're asking us for when this is going to be greater than 0. It's going to be greater than 0 out here. This is where the function is greater than 0 out here. So the function is greater than 0 when x is less than this value or when x is bigger than that value. All right? Nice and easy. So let's do this. So let's write down our solution now. Our solution then, right? Our solution is going to be x is less than -1/3. -1/3. X is either less than -1/3 or x is greater than 5/2. That's the solution. X is either less than -1/3 or x is greater than 5/2. And that's the solution. Nice and easy. Soft. So far, nothing biggie, nothing too tricky. Everything nice and easy. Okay, now let's look at the next part of the question. Part 3. Part 3 is a sequence and series question. Let's hear what they have to say. They say that a customer is doing what? It says a customer repays a loan monthly by increasing the payment each month by X dollars. It says if the customer repaid $50 in the 5th month and $70 in the 9th month, calculate the amount of money repaid by the end of the 24th month. So notice what they said. They said that in the 5th month, so the 5th month, so the 5th, I mean, like to use common letters, the 5th month payment, as we can see, that was $50, all right? And it said that in the 9th month, the payment was $70, all right? And it says each month, the payment increased by X dollars, all right? So the monthly increase is equal to X dollars, all right? But clearly we can decipher what the monthly increase is already, because if it's increasing by X dollars, in the 6th month, you pay $55, in the 7th month, you pay 60, 8th month, 65, 9 months, 70. So clearly we can decipher that X is equal to 5. We've done that already. X is equal to 5. All right, so X is equal to 5. So each month you're increasing the payment by $5. So pretty much, since we know that we were increasing the payment by $5, we can tell what is the first month payment. The first month payment, as we can see, would therefore be 50. In the 4th month would have been 45. In the 4th month would have been 45. In the 3rd month would have been 40. In the 2nd month would have been 35. In the 1st month, so the 1st month payment, would have been equal to just $30, right? So to find out how much you're going to pay at the end of the 24th month, then this is a sequence question. You can do it 2 ways, and I'm going to show you both ways. The first way is to say that the sum, I like to write S for sum, the sum of the first 24 months pay is a sequence question. Remember, sum, before I even write sum of the first 24, let's just write down back the formula for Sn, because it's a sequence. Sn is equal to n over 2 times 2a plus n minus 1 times d. All right, so this is the formula for Sn, and as we were saying now, you can replace n with 24 because it want the total amount that you're going to pay for 24 months. So it would be S24 is equal to 24 over 2, which is going to be 12, times 2 times A. A is the first monthly payment, so it's going to be 2 times A. A is 30, so it's 2 times 30 plus n minus 1. N is 24. 24 minus 1 is 23. And 23 is then multiplied by the monthly increase, which is 5. And this will give you the sum that would have been paid for the first 24 months. So if we work this out, we're going to get 12 times 2 times 30 plus 23 times 5 times 12. That's $2,100. That's the total amount of money that would have been paid for 24 months, $2,100. That's method 1, all right? That's method 1. As we all know in mathematics, there's always multiple ways of doing it. So this is method 2. This is for the lazy persons, method 2. Since it told us that it's increasing by $5, we could have said that the sum is equal to first month payment 30 plus second month payment would have been 35 plus 40 plus 45 plus 50 plus 55 plus 60 plus 65 plus 70 plus 75 plus 80 plus 85 plus 90. Now how many months would that be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 plus 95 plus 100 plus 105 plus 110 plus 115 plus 120 plus 125 plus 130 plus 135 plus 140. How many is that now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 plus 145. That would have been 24. Now, you add up all of these and that will give you how much money is paid over 24 months. So 30 plus 35 plus 40 plus 45 plus 50 plus 55 plus 60 plus 65 plus 70 plus 75 plus 80 plus 85 plus 90 plus 95 plus 100 plus 105 plus 110 plus 115 plus 120 plus 125 plus 130 plus 135 plus 145. Ooh, so much adding. And you'd have gotten your same $2,100. All of that for that. Nice and easy. So either way, you check it out. You get your $2,100. All right, so as I was saying, method 2 is more for the lazy persons that can't bother to remember this formula. And method 1 is the proper way to do it. So this is this question. Nice and easy. Soft. That takes care of question 1. Let's go to, well, that takes care of section 1, not question 1, section 1. Now let's go to section